Good afternoon, everybody. Welcome to a sunny Tuesday afternoon of Chem 170, Organic Chemistry, with your host, me, Dr. White. I hope you all had a nice time since we last met. Now, a couple things I like to talk about. First of all, as many of you have already found out, I posted yesterday's meeting, our Zoom lecture meeting, on my YouTube channel already. And let's go there. All right, here's the YouTube channel. Wow, who's that handsome guy? And something I realized last semester that I'll do now that students hadn't figured out, if you look at the file name, 20220606, that's year, month, and date. So that was yesterday's, the 6th of June this year, 2022. Boy, it just seemed like 1995. Never mind. But anyways, it's posted. And if you notice, there are 10 views already. So either 10 different people watched that or a couple people watched it a lot of times. I don't know which, but it's out there. Now, if you want to get ahead of the game, you can go back and look at other ones I've done. Now, last semester, for reasons, technical reasons, the first lecture, I couldn't post a Zoom meeting. After that, I got them all. But if you go to last summer, if you notice, until I get into double digits, you can see the week number on the title. Oh, who's that guy peering out? But anyways, you can go back and see the first week right here. So if you want to get a head start, here we are last summer. Now, last summer, it was an 8-week course. This was 7-week. So we're going to be a little more compressed. But if you want to get ahead of the game, you can go back and look at these. And one of the things I should point out, which I did here, and I'll do every of these videos. If you click on more, you'll see everything I talked about. And that's that video. All right, another thing I wanted to bring up is posting videos. After we have our lecture, it takes the Zoom meeting software about, for like yesterday's lecture, about 25, 30 minutes to convert it into, I believe it's an MP4 file. Then I take that and then I edit it. If you ask questions at the end of class, after class, I always cut that out. And then I'll put a title beginning, the end at the end, profound. And then I do that with my editing software, and that processes it all together. That thing takes me actually about 10 minutes doing stuff, but it takes my software another 30 minutes. And then if I don't have office hours, what I'll be doing is uploading it to YouTube. And depending how busy YouTube is and factors I don't know, this company I now use, I used to use Wow, and Astound bought them out a couple of weeks ago. They switched over. I was at the past had a 50 meg or gig upload. Now their max is 20. So that takes anywhere from 35, 40 minutes to an hour and a half, depending on how busy YouTube is. So realistically, after a afternoon lecture or lecture lab, figure by 8 to 10 o'clock, sometimes even if something comes up in my personal life, tomorrow, the next day morning, I will have the video. Usually by the end of the evening, 9 or 10 o'clock or a little earlier, I'll have it there. But don't look for it like 6 or 7. That's still a little too quick. All right, that's out of the way. It's time for a public service announcement from the management, me. And that public service announcement is, let me see if I can find it. and I can. And the public service announcement is from the file Alkanes IUPAC name and number of carbon atoms, you should know this chart like you know your own first name. I'm going to assume all of you know your own first name like that. Oh, I put new batteries in there. It's working. But anyways, remember I told you I use humor and you got to suffer through it. But anyways, you should know methane 1, propane 3, hexane 6. I won't even look. Decane 10. Oh, I got it right. But you should know these. If you don't know these, you've just lost about 50 points on test 1, and you've lost about 35 points in test 2 and 3, and a lot of points on the final. You need to memorize this. You can use flashcards, but I showed you yesterday. Remember propane, 3 carbons, CH3, CH3, CH3. Write it down, say it 5 times. The other chart, and we'll be going through this today, you need to also know is this one, the key alkyl groups. And yesterday I talked about a methyl group, CH3, attached to something. And once again, you need to know these, because if you don't know this table, like you know your first name like that, then guess what? You're going to lose about 50 points from test 1, which I don't want to see that happen, and I'm sure you don't. Black blueberry tea from the Republic of Tea. Yes, Dr. White is the tea drinker. All right, so write down CH3, the name methyl, and say it. Do it again. Do it 5 times. Both of these tables, the alkanes, names and numbers of carbon atoms, and key alkyl groups are in the lecture folder of D2L. If you can't find it, email me. I'll send it to you, but you should be able to find it. If not, ask for help. Remember, in my class, there's no such thing as a dumb question. And I would expect or hope, I shouldn't say expect, hope, that by this Thursday or at the latest Monday, you know both of these tables by heart as well as you know your own first name. And that's my public service announcement. Any questions before we get back to IUPAC nomenclature rules? But they're very important. It's sort of like eating dry white toast when you could have had a full 5-course meal, but both will keep you alive. All right. Any questions? Nothing. All right. Let's get back to what we were talking about. Remember, IUPAC is an acronym, and I like to say International Union of Pure Applied Chemistry, and that's the organization set up, and I'll never ask on a test, what does the IUPAC stand for, but I think it's just cool to say, and I do. They're responsible for the rules, how you name chemicals, and the majority of their chemical names or rules are for organic chemists, for organic chemicals, really. I should point out, when they do rules, they put them in a book. They used to put them in a book. Now it's, I believe, it's on their internet site, and they'd have a color. And I think the gold book was something like over 3,000 pages of just rules, how to name them. Do I know everyone? No. Do I know everyone in the areas I work with? You better believe it. Actually, you should believe it, because I do. And you'll be learning them, this not all 3,000 pages. I don't know them either. All right, let's get back to where we were. We're talking about alkanes and how do you name them? And the question is, how do you name it? You have to find the longest chain. First of all, if it's acyclic, meaning not in a ring. Now, one of the things I wanted to point out, thumbs up, people. Can you see Chapter 2, Alkanes Practice Problem? Thank you. All right. Now, I'm not going to do these now. Remember what I said yesterday about riding a bike, watching the DVD or Blu-ray. Let's get the good stuff, the Blu-ray. until you get on a bike. First time you get on, you fall off. Well, these are to help you. And notice the first problem that you should be working on, how many carbons are in the longest chain. I didn't even put any hydrogens in so you wouldn't get confused. And then what we started doing, we'll do more today, give the IUPAC name for the following molecules. We start doing this. And later today, there's two skills when it comes to IUPAC names. One is, here's the molecule, give the name, IUPAC name. Excuse me, getting all choked up over this stuff, not really. But anyways, and the second one is draw the condensed structure for the following. In other words, here's the name, draw the structure. And those are important. We'll do that today. And after we do this, you should go here and practice these. After test number 1, you'll know why I call them practice problems. Hint, hint, big hint. Anyways, let's get back to, and I think it depends either today or tomorrow. I'll know either Thursday or Monday. I'll go through some of these with you. When we go through practice problems, so I go through every one? No. But if you're here live in person, then you can ask questions. And if I don't cover the ones I pick myself, you can ask and I will do that. All right, we're talking about how to name alkanes. And let's go to my whiteboard. And remember, your job is make sure every carbon has 4 bonds to it. If not, tell me. Now, here the question would be, in real life, the thing is, I do this to get your attention, which it just did. And since one of your colleagues asked, could I make sure I print? I will. And if you can't read my printing, you can always feel free to ask, what the heck is that? All right. Now, the first step in finding the IUPAC name is find the longest chain. And guess what? I'm going to share some of the fun. I'm going to let you first try and figure out what is the longest chain. So, ready, set, go. Remember, this is a lot of fun. And something I remember to do is the following. Oh, I'll wait a little while. And all I'm asking you to do is find the longest chain. Remember, chain means carbon atoms linked together like a chain. I like those visual effects. All right, let's take a look at this. What's the longest chain? Well, I'll count across 1, 2, 3, 4, 5, 6, 7. Oh, one thing I should point out, I write my sevens like this. Ooh, better than that. Anyways, back when I was in high school, I had a great German teacher who was from Germany, Herr Brink. Herr means Mr. And that's how he wrote his sevens. And I thought that was the coolest thing in the world. And I've been doing it ever since. It is the coolest thing in the world. Not really, but anyways. All right, let's look at another one. Start here. 1, 2, 3. Now 3 is linked to this carbon, so that would be a chain of 4. And there's one other chain we can do. We can start here, 1, 2, 3, 4, 5, and then come down to here again, and that would be 6. So we have 3 choices, and those choices are 4, 6, and 7. And you want to find the one with the longest chain, the largest number. So you got to use your high-level math skills, which largest number, and hopefully all pick 7. So that's the longest chain. And that's the root name. So once we found, and let me go through it again, you count the carbons connect together in the longest chain. Remember, chains don't have to be straight. They can all wiggle around. And here, it's 7. So first of all, let me clean this up a little. Now, what's the IUPAC name for the root chain or branch chain for 7 carbons? Well, hopefully, hint, you've learned this chart, and 7 is heptane. So the root name is heptane. And as soon as you say heptane, all of that is spoken for. Now on a test, no, you don't have to circle it and you don't have to put the numbers down. I do, so you can learn how to do this. So are we done? No, look what's left over. A substituent. And this is called an alkyl group because it's only carbons and hydrogens. And if there was more than one carbon, it's carbon-carbon single bonds. In this case, it's not. And it's CH3. And the question is, what do we call that group? That alkyl group. And hopefully by Thursday or Monday at the latest, hint, you've learned this table. 1 carbon, CH3, is called a methyl group. So this is a methyl, and it goes in front of the root name. Are we done? No. Just like when you have a postcard or letter you're sending to someone, you have to put not only the street name, but the number of their house, condo, or apartment. And here we start from either end. Common mistake on test number 1, and I'm telling you this so you don't make that mistake, is students call, oh, there's only one alkyl group, we'll call that carbon 1. No, it has to be this way. And if I start from this way, going this direction, it's on carbon 3. If I start this way, 1, 2, 3, 4, 5, it's on carbon 5. When you're numbering alkyl groups, if you have 1 or more, you start from the end that gives the lowest overall numbers. Again, when you have 1 or more alkyl groups, you start from the end of the chain always, and you number it so you get the lowest numbers In this case, 3 is less than 5. So this is 3-methyl 5-heptane. Got my mind mixed up. 3-methyl heptane. I was looking, I saw the number 5 and my brain went, ugh. All right, let's do it again. And if we were face to face, you'd have to patiently wait while I put in the hydrogens. All right, again, the question is, by the way, this means new stuff into the line. I don't know where I picked that up. But anyways, what's the IUPAC name for this molecule? And the first thing you have to do is find out what's the longest chain. Your turn. And since you haven't learned, probably not, but hopefully you will, the alkane names, I'm going to just ask you right now, find out what's the longest chain. Oh, I see a question. Remember, I see somebody already beat me to it. I'm going to let you teach the course. All right, let's do my poll. Remember, if you're taking this course again, a number of you have indicated you are on the roster. If you need help, come to my office hours on Monday and Wednesday. If you're here during class, ask questions, because remember, there's no such thing as a dumb question. All right, let's find the longest chain. And if we come here, I'm going to count across 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, 10 carbons. Now, let's look for other chains. Well, I've got one here. 1, 2, 3, 4, 5, 6. And there's another chain. 1, 2, this is bond here, 3, over here, 4, 5, 6, 7, 8, 9. Wow. So we have 3 chains. And the choices are 6, 9, or 10. Which is the largest number? Hopefully you all pick 10. And you'd be correct. So let me clean this up a little. All right, the longest chain is 10. And you hopefully by Thursday, if not sooner, you have memorized this chart. 10 carbons, decane. So the root name, because it has 10 carbons, is decane. Now, as soon as we say decane, That's all spoken for. Are we done? No, there's an alkyl group hanging here, a branch. So how do we name that? How many carbons? 2. And hopefully by Thursday or at the latest next Monday, hint, you have learned a key alkyl groups chart. 2 carbons right here is called ethyl. So that's an ethyl group. Now, are we done? No, you have to, which carbon is the ethyl group on? Remember, you can only start from the end of a chain, never anywhere else for acyclic alkanes, or alkanes are acyclic. And if we start from this side, 1, 2, 3, 4, 5, 6, 7. So if we start from this side, it's on carbon 4. We start from this side, it's on carbon 7. And the IUPAC rules are you take the lower number, and hopefully I'll pick that's 4. So this is 4-ethyl decane. Remember, there are 4 bonds to carbon. That's how I know how many hydrogens putting on this compound. And the question would be also give the IUPAC name for this. Now I'm going to do this. What's the longest chain? Well, going across, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I start here, I can do 1, 2, 3, 4. Nope, that's less than 9. 1, 2, 3, 4, 5, 6. Nope, that's less than 9. And I could do 1, 2, 3, 4, 5, 6, 7, 8. That's less than 9. So the longest chain is 9. So if we look at the table that you should know by Thursday, which is located in D2L, 9 carbons, is nonane. So the root name is nonane. And now, as soon as you say that, that's all spoken for. And look, we have not 1, but 2 alkyl groups, 1 carbon and 2 carbons. And hopefully by Thursday or the latest Monday, you have memorized the key alkyl groups, 1 carbon methyl, 2 carbons ethyl. Now, IUPAC has rules for what order in the front the alkyl groups or other groups are ordered, and that's by alphabetical priority. The beginning of the alphabet alkyl groups come first, and then those afterward. Now, therefore, this is an ethyl group. This is a methyl group. The ethyl would come first because E is in front of the alphabet, M is after E. Now, we also need to know what carbons they are. If I start numbering from here, if I go this way, the methyl group is on carbon 3 and the ethyl group is on 4. If I go the other way, the methyl group is on 7 and the ethyl group is on 6. And the IUPAC rules are you write you give assigned numbers such that you always use the lowest numbers, 3 and 4. So how do we do this? It would be 4 ethyl, 3 methyl, no name. And that's how you do it. Now, it's time for a special gift from me, Dr. White. Now, when you get to some of the other alkyl groups, if it has a prefix like N or tert or iso, you look at first the root name of the alkyl group, and that can get some confusing, really. So my gift to you is, on my test this semester and the final, don't tell anybody I'm being nice, I'll ruin my image around here. But anyways, I will not hold you to the alphabetical IUPAC rule for alkyl groups, which order goes first. I will always do it correctly, at least I hope I do. Usually I do, but when I do it in class, and also when I talk about the right answers in the problem sets. However, there would be other answers I would accept on a test. And for this one, if you had put 3-methyl, 4-ethyl, no name, which I gotta force my hand to do this because it's not the right thing. This is the correct IUPAC because of the order. But if you did it this way, I give you full credit on the test. And that's my gift to you. Now, all right, let's look at this example. And for this one, I'll do the longest chain. Remember, you have practice problems you can do on your own. And the longest chain is 5. And what's the root name? You have learned this table, 5 carbons is pentane. Remember, you should know this table like you know your name that quick. Ooh, that was soft. That was, uh-oh, I'm running out of juice here. That's better. This is as well as you know your first name, 5 carbons pentane. So the root name is pentane. And as soon as we're say pentane, those 5 carbons are spoken for. What do we have left? Oh, a CH3 group, alkyl group here, a second one. And oh, it's your old friend, the methyl group. Remember, by Thursday or latest next Monday, you need to memorize this chart too, the alkyl groups. And these aren't the only alkyl groups, but for this class, these are the key ones I'll be teaching you. And CH3, methyl group. Now notice we have not 1, but 2 methyl groups. So how do we show that? Right here. When 2 or more identical groups are attached to the main chain, prefixes di, tri, and tetra are used. I don't have a slide for it, so di is 2 groups, tri is 3 groups, and tetra, which I've never used, but I put it down just for the fun of it, is 4 groups. but di you should know is 2 groups. Tri is 3 groups, and those you should know. Now we have 2 methyl groups, so which one do we use? Di. So this is dimethyl. Now, one of the beauties of IUPAC rules, in my mind, it is quite beautiful, is that you never have to guess. And therefore, I have 2 methyl groups. I need 2 numbers where the carbons are the on. If we start from this side, 1, 2, 3, 4, it's either 2, 3 or 3, 4. Which are smaller numbers? Hopefully you pick 2, 3. And how do we show that? 2 and then between numbers that are different, comma, 3 dimethylpentane. Oh, that's a pretty name. Now you know I'm an organic chemist. And therefore, this is 2,3 dimethylpentane. And that's how you do it. All right, your turn. Why don't you figure out what's the IUPAC name? First, why don't you find out how many carbons are in the longest chain? And then what's its name? Hint, it's on the screen. And then what alkyl groups, and then number them. Boy, am I sharing the fun with you today. Oh, by the way, in case I forgot to mention, it's National Turn On Your Webcam Tuesday. Did that work? Shucks. Remember, always, if you have questions, always feel free to ask. Because in my class, in my world, there's no such thing as a dumb question. And you're all starting out. I remember the first time I learned this, and it took me a while to get my head around it. All right, let's get to work. What's the longest chain? And that's 5. Pentane. You could have gone here or here, and it'd still be pentane. If I go like this, that's 3, or go up, it's 3. So 5 carbons, as we just mentioned. I mentioned. Don't you like how I use the imperial we? But anyways, pentane. As soon as you say pentane, that's spoken for. Are we done? No. Oh, we've got our old friend, the methyl group. Not 1, but 2. And methyl is the name of the alkyl group, and we have 2 groups. Remember, di is 2 groups. tri is 3 groups. Well, this is 2 methyl groups, so that's di. Methyl. Now, as soon as you see the word prefix, prefix is the stuff that goes in front of a word. Di, that means 2. Each group has to have its own number, even though if it's on the same carbon, like this example. Because if I just said, if I start from this side, it's either a carbon. Remember, you always start from the end of a chain, never in the middle or anywhere else but then. I can either have 2 or 4, which is smaller. Hopefully I'll pick 2. Now, students make the mistake, oh, I just put this down. And the answer is that's wrong. And why is it wrong? Because I know where one methyl group is, but I don't know where the other one is. I'd have to guess. And IUPAC names you never have to guess. So they're both on the same carbon. How do we show that? This is 2,2-dimethyl pentane. And that's how you do it. Again, you can find the longest chain, name it, name the alkyl groups, and name what carbons they are on, or write down. Now for something real neat and real world, which is always fun, in Milwaukee is headquartered, actually they were bought out by another company years ago, but this part of the company is still in Milwaukee. There's a great chemical company called SigmaAldrich. It used to be Aldrich Chemical Company. And they are the best supply in the world, not just the United States, the world, for small quantities of chemicals. And what I mean between difference of small and large, if you need a pound or 2 of something, you go to SigmaAldrich, or I'll probably just say the old name Aldrich. If you need 40,000 pounds, you don't go to SigmaAldrich, you go to another supplier who deals in bulk, or the company that makes it. And let me just show you their website, because it's a neat place to go to. That's not what I wanted. That's what I want. That's what I wanted. And nice thing about SigmaAldrich, you can get structures and other interesting things from them. If you notice here, if I click on hexane, they'll show you the structure. Now they use the condensed and 2 carbons plus 4 more hexane. Now, I've never seen anybody call it N-hexane. But anyways, then they sell at different amounts and you can buy from them. And I think I started buying from them, I hate to say this, back in about 73 when I was in grad school. Yep, that long ago. Oh, I shouldn't have said that. Ouch. But anyways, this is a neat place to visit. I thought I'd share that with you. All right, so we've gone through the IUPAC names for alkanes and substituents. Now, substituents, as I said, are groups or atoms that are attached to the main chain or ring of carbon atoms. Now, we've gone through the alkyl groups. They're also halogens. Remember in the periodic table, Fluorine, chlorine, bromine, iodine are the halogens. I've never worked with astatine and this other one, tennessine or whatever, But fluorine, chlorine, those are the halogens. We'll talk more about it during the semester because they're important to put on organic molecules. And I'm going to hold off until we get to aromatic compounds to talk about nomenclature of halogens. Now, we've already done the alkyl groups, and back when we were face to face, I'd be writing this on the board. But let me just remind you, you should be memorizing this table along with the alkane's name. This table by Thursday, you should know this at latest Monday. Hint. Should I be subtle again? Hold on, let me be real subtle. You should know these tables. Yes, you should. Subtle. By the way, the company that makes this is no longer in business. It's from West Germany. I've got 4 of these. They never leave my house because you can't get those quality anymore. Now, later on, I'll teach fluoro, chloro, bromo, and iodo. All right, let's talk about cycloalkanes. But guess what time it is? It's time for our break. So let's take a 5-minute break, come back at 2:50. That's when the big hand is on the 10. If you have an analog watch, if you have a digital, 2:5 or 2:55. What am I saying? 2:50. 2:55, big hand on the 11. And I'll see you in 5 minutes. I can go stretch. get started. Everybody back? All right. Let's continue on with IUPAC nomenclature. Remember, today's a Tuesday, so later today we'll be doing our lab. Now, when we talk about cycloalkanes, we're talking about the fact that, and let me get my model out and have some fun. Here I have a chain, and remember in real life, they're not straight across, and they can flop all the way around. 1, 2, each center, 3, 4, 5, 6. And a ring is when you take the ends of a chain and bring them together, and you form a ring. Having fun with organic chemistry. And this is called a ring. Even though it's really a hexagon, we call it, organic chemists, a ring. Now, the question is, how do you name rings? And actually, I just made a mistake. So I'm going to back up, north, like if you were rewinding it, say, and let's go through something right here before we go on to rings. We'll get to them in a minute. And that is, there are two skills in nomenclature. One is, here's the molecule, give the IUPAC name. And the other is, draw the structure from the name. And sometimes I'll say, give the structure. Now, when I say draw the structure, I mean show the actual structure. Do not give the empirical formula, the number of carbons, hydrogen, other atoms. That's totally worthless to organic chemists. The actual structure. So let's look at how we would do this. And if we look at this, it says draw the structure A, 3 points each, propane. How do you do that? You've learned this table, propane, 3 carbons in a straight chain. So now come here, 3 carbons, but I have to put in the hydrogens. You know, there's 4, yes, 4 bonds to carbon. And we did this. This one has 1 bond. 4 minus 1 is 3. So it has 3 hydrogens. Same thing here. This carbon has 2 bonds to it. Count the lines. And 4 minus 2, remember there's always 4 bonds to carbon, is 2. And there you have propane, which you should have remembered hopefully from yesterday. Now, your turn. Draw the structure for butane. Now, I'm going to help you out. You can't do this on the test, and I'll know if people are cheating. I've got secret things in there. How many carbons are butane? Hopefully you'll memorize this by Thursday or latest by Monday. 4 carbons. And I'll let you figure out the rest. one thing, if you're finished early, please be patient. I try and give everybody a chance to finish. If we were in a classroom, I'd say when you're done, look up and smile. I say that now, but most of you don't have your webcam on. Which is why I use the poll. All right, let's do this. Remember butane. Did I say pentane earlier? Butane, 4 carbons. And now this carbon has 1 bond to it. It should always have 4. Therefore, 4 minus 1 is 3. This carbon has 2 bonds, 4 minus 2, 2. Same thing here. And this carbon has 1 bond to it. Should always have 4. And there you go, butane. By the way, that's the liquid in those little plastic lighters. Hopefully you've given up cigarette smoking. If you are, decades ago, I was a heavy smoker, and luckily I gave it up decades ago. All right, let's continue on. This one I will do. And the question is, draw the structure for 3-methyl-octane. Well, how do you do this? How do you decode this secret words, not that secret though, to get your 3 points and draw the structure? And here's how you do it. In organic chemical names, you always start from the right and move left. So I see octane. And hopefully by Thursday, if not, oops, wrong one. Octane, you've learned this table, is 8 carbons. So I have octane. I have 8 carbons. It's always good to put the hydrogens in last. Well, that's spoken for, and I'm going this direction. I have methyl, and hopefully, you've learned by now, methyl is CH3. And where's that CH3 group? On carbon number 3. And you can number from this way, 1, 2, 3. And now I'll put in the hydrogens. Remember, there's 4 bonds to carbon. And here we have 3-methyl-octane. But you would say, wait, Dr. White, what if I did this? I have octane. And what if I started here? 1, 2, 3. My methyl group would be there. Excuse me. And now I'll put in the hydrogens. Remember, it's your solemn responsibility, that's the 2 here, to make sure I put in the right numbers. And let's call this A, and let's call this B. Which is the correct one, A or B? And the answer is both. Molecules like you and me are not glued just in one place. We move around, so do they. And let me show you something. If I were to say, oh, look, my left hand, and I'd say, close your eyes, and while your eyes are closed, I went like this, and say, oh, look, something different. And you'd say, oh, come on, you just rotate your hand 180 degrees. It's still your left hand. And guess what? Molecules can rotate, just like this pen can rotate all over the way. And therefore, either one is correct. And aren't you glad your instructor, me, has a piece of paper signed by the Board of Regents of Michigan State University saying, I understand that, my PhD degree in synthetic organic chemistry. So let's look at how we did this. We want to know how to write 3-methyl octane. You start from the right. Well, that's the ugliest looking arrow I've ever drawn. Let me get. You start from the right and move left. Octane, 8 carbons, longest chain. On carbon 3 is a methyl, and that's how we do it. And here's one for you to try, 4-methyl decane. Now, let me help you out. Hopefully by Thursday or Monday, everybody getting the hint. Dr. White's being overkill. I remind you, you memorize this. Decane is how many carbons? 10. So I'll let you continue on. Draw the structure for 3-methyl decane. Oh, tonight at midnight, I'll be giving speed structure drawing lessons. No, I won't. Don't forget to vote. All right. Let me do it now. How do you decode this to know what to draw? You start from the right and you move left. And decane tells you 10 carbons. 10 carbons. And now we keep on going. Oh, it's your old friend, the methyl group, CH3. And where is it? It's on carbon 4. So I have 1, 2, 3, 4. And methyl group is CH3. Now I could have started here 1, 2, 3, 4. And most of you don't. I might, but you wouldn't. So I'll just draw this one structure. The rest of the semester, if there's more than one way to draw it, I'll draw the one that for now, most of you will probably draw. And if you have questions, you can always ask. And now I know there's 4, yes, 4 bonds to carbon. And that's how you do it. All right, let me show you another thing. Whoops. All right, let's look at the name 4-ethyl, 2-methyl, no name. Now, you know something? I'm going to let you try this on your own first, and you start from that. Oh, I gave it away. But in case you haven't memorized, which you probably haven't, if we were in a classroom, I'd have both of these written on the board, but no name, how many carbons? 9 carbons. No name, 9 carbons. And the key alkyl groups, here's a methyl group, here's an ethyl group. There's a methyl, there's ethyl. And I'll let you first draw the structure 4-ethyl, 2-methyl, no name. Say that 5 times quickly. No, you don't have to. Nana, I like how you try to do that in the chat. Cute. Thank you. All right. Let me put out a poll. Remember, if you're having trouble, always feel free to ask questions. And later tonight, I'll have today's lecture on my YouTube channel, so you can always go back and watch us again. And don't forget to vote on the poll or click yes or no when you're done. All right, let's do this. How do you do this? You start from the right and you move left. No name. As I showed you on the chart, you should know by Thursday or Monday at the latest, 9 carbons. Now, we have a methyl group on carbon 2, and I'll start here 1, 2, 3, 4. So I'm going to put a methyl group, 1 carbon. On carbon 4 is an ethyl group. Now you can draw the carbon on this side or this side, the second one. It doesn't matter. And now there are 4 bonds to carbon. Let's look at this carbon on 2. How many hydrogens should that have? Well, I see 1, 2, 3 bonds. There's always 4 bonds to carbon. 4 minus 3 is 1. So that's 1 hydrogen. And now I'll fill in the rest at warp drive. For those who know science fiction, that means real fast. But then again, don't forget, I've been doing this a few more months than you have. Is that an understatement? And that's how you do that. Let's go through it again. You start from the right and move left. You see no name, 9 carbons. And that's what I drew. And then on carbon 2 is a methyl group, CH3, and on carbon 4 is my ethyl group, CH3, CH2. And it's time to move on. I'm glad I remembered not to forget, I didn't forget this. All right, let's talk about rings, cycloalkanes. Good news, they're similar nomenclature. Remember, nomenclature is a fancy word meaning to name for alkanes. Now, here's where they're a little different. The ring portion serves as the base name, but the prefix cyclo is used to indicate the presence of a ring. So let's take a look at what that means. Now, when we do rings, we don't show carbons or hydrogens on the ring. So every bend in the line is a carbon. So let's count them. 1, 2, 3, 4, 5, 6. What do we call 6 carbons? Well, time to be obnoxious again. Remember, by Thursday at the latest Monday, you should know this chart by heart. And 6 carbons, alkane is hexane. So we go back here and we say, well, this is hexane, but it's a ring, so you need the prefix cyclo. So the name of this compound is cyclohexane. Common mistake students make on test 1, they forget the cyclo. And if you put down hexane, and I give you 0 points, and you say, Dr. White, don't I get any partial credit? And guess what? I'm going to say no. If I say on an anatomy and physiology test, I've never taken that course, not there's anything wrong, but I'm an organic chemist, but enough of my students have. If this, you ask, what's that? I don't think they'll be on test, but if it was, and you put down foot, would you expect to get partial credit? Well, it's got 5 digits like my foot. Don't I get? No. So don't forget, for a ring, you need the prefix cyclo. All right, let's do another one. And I'm going to ask you to figure out how many carbons are in that ring. Your turn first. See, I do share all the fun here. I'll give you 8.67 more seconds. 8.2, 8.7, strange watch. Time's up. How many bends in a line tells you how many carbons? 1, 2, 3, 4, 5. It's a ring. Even though you call it a pentagon, organic chemists call it a ring. And the base name is, from this chart, 5 carbons is pentane. But because it's a ring, we use the prefix cyclo, and then 5 carbons, pentane. By the way, whenever I look at cyclopentane ring, I think of the little greenhouses in Monopoly. I have a sister who's 7 years older, one 7 years younger. And before the younger one was born, if we were both home from school sick, we'd play Monopoly. And whoever went to the bathroom, the other one always stole from the bank. Yeah, we played cutthroat Monopoly. But anyways, that's cyclopentane. Let's do another one. You call that a square? No, it's a ring. How many carbons in that ring? Give you 2 more seconds. Bonus time. Time's up. Count the bends. 1, 2, 3, 4. 4 carbons is butane. Hopefully you've learned that table by Thursday. And it's a ring, so we need the prefix cyclo. Don't forget that. Students lost a lot of points on test 1 because they put down this butane, and that's wrong. Now, one more ring. How many carbons? Let me clean this up a little. A lot, I guess. Yeah. How many carbons in that ring? No, it's not a triangle. It's a ring. This is organic chemistry. And the answer is 1, 2, 3. And its name, 3 carbons, propane. And it's a ring, so we need cyclopropane. Remember, don't forget the cyclo. Now, you can have larger rings, but most things we do in organic chemistry and Mother Nature, these are the key rings. Example, there's a 4-membered ring in penicillin. In your hormones, otherwise known as your steroids, and we'll talk about that later this semester near the end. You have 3 6-membered rings and a 5-membered rings all connected together. So rings play an important part in our daily life. If you don't think so, think about your hormones. If you didn't have hormones, I don't know, what would that do to your body and your life? Cause serious problems, I bet. By the way, I'm an organic chemist, and the last biology I took was freshman year of high school, not because there's anything wrong with biology, but by that time I already knew I was going to be a chemist, and I did become one. All right, One last thing, and you don't have to write this down. This has 8 carbons. Not the best one. Let's see if I can do a better one. That's sort of better. Well, anyways, 8 carbons is octane. And it's a ring. Don't forget cyclo. And whenever I'm driving around and I come to a certain special thing, I think of cyclooctane ring. And what is that? Stop signs. Hold on. I've got internet, so I can do the following. And if you look at a stop sign, and this is the outside, that's a cyclooctane ring. And whenever I come to a stop sign, I'm an organic chemist, I think of cyclooctane, even though in real life, we don't use it that much. All right, so the root name, and these are the ones I'm going to be using, so you should know, 6-membered ring, hexane, it's a ring, cyclohexane. 5-member ring, pentane, it's a ring, cyclopentane. 4-membered ring, butane, but it's a ring, cyclobutane. And 3-membered ring, propane, but it's a ring, cyclopropane. And the main ones in our life and Mother Nature uses are 6, 5, and 4. There's some 3, but it's rare. Now, let's skip down to this one. I should have changed the order. If only one substituent is present, then no number is needed. This is important. If only one substituent is on a ring, no number is needed. So how do we name this compound? First of all, we've got a ring. How many carbons are there? 1, 2, 3, 4, 5. 5 carbons is pentane. It's a ring. Don't forget the prefix, cyclopentane. Are we done? No. Oh, look, it's your good buddy, the methyl group. So that would be, hold on, this happens even on a whiteboard. This will happen to me. That's better, methyl cyclopentane. Now let's look at this molecule. Remember, when there's only one substituent, you don't need a number. And what would be the IUPAC name for this? Let's call this A, let's call this B, one from column A, one from column B. All right. And what do? We've got a ring. And it's pentane. It's a ring cyclopentane. We have a methyl group. Well, you'd say, Dr. White, isn't A 1-methyl cyclopentane and B 2-methyl? No. IUPAC names, you never have different names for the, let me rephrase that. One molecule only has one name if you do it correctly. And we always try and do it correctly. And why aren't these different? Well, here's my left hand. If I say, close your eyes, I go like this, and I say, all right, open, look, something different. You say, oh, come on, you just rotated your hand like that. Well, with a ring, I've got a 6-membered ring. Methyl group ring. Is this different from this? No. Or I could also put it down here. They're all, in this case, 1-methyl cyclohexane. So when you have one substituent, you all don't use a number. So if we look at the following, it says give the IUPAC name for, and remember IUPAC name stands for the official name. You don't have to know, even though I think it's cool to say International Union of Purified Chemistry. But how do you do that? Oh, we've got a ring. How many carbons in that ring? I'll give you 4 seconds to figure that out. Bonus time. Time's up. And the answer is count the bends. 1, 2, 3, 4, 5, 6. 6 is hexane. But it's a ring. So don't forget cyclohexane. Students do that in test 1. I'm telling you, don't, so you don't make that kind of stupid mistake. Then again, has anybody ever made a smart mistake? Well, anyways, cyclohexane. And now we have this alkyl group, which I haven't talked about. Now, if we look at that alkyl group I just circled right here, how many carbons? 1, 2, 3. Notice that the 3 carbons, the center carbon is bonded to the ring. And hopefully by Thursday, at latest Monday, you know this table. And notice 3 carbons, you have 2 choices. And the second choice, you have 3 carbons, CH3, 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 and the center carbon is bonded to something. That's why I have on this table that line to the center, and that's called an isopropyl group. 3 carbons to the center, isopropyl group. And remember, when there's only one substituent on a ring, you don't use the number. So that would be isopropyl cyclohexane. Your turn. What's the IUPAC name for that molecule? Hopefully by now you figured out there's 6, yes, 6 carbons in a ring. And I'll help you out because you probably haven't memorized this yet. 6 carbons is hexane. Your turn to finish up. All right, looks like everybody's done. So let's do it. First of all, we have a ring. Count every bend, 6 of them, hexane. But it's a ring, so you need the prefix cyclo. So it's cyclohexane. And we have left, oh, it's your old friend, the methyl group. And remember, when there's only one substituent, no, that's not 3-methyl cyclohexane. When there's only one substituent, you don't use a number, because that would always be carbon 1. Why write down something you already know? You don't need a number. And that's what IUPAC said. All right, let's look at another one. Now, if we look at this, how many carbons in a ring? 6. 6 is hexane. And it's a ring, so it's cyclohexane. Here we have a methyl group, because you've learned the table of the alkyl groups. And here we have an ethyl group. Now, if we look at this right here, 2 or more alkyl substituent groups are named and numbered the same as alkanes, except the alkyl group with the highest alphabetical priority is located at carbon 1. Again, if you have 2 or more alkyl groups on a ring and they're numbered the same as the alkyl groups, and I'll show you, except the group with the highest alphabetical priority, that means closest to the front of the alphabet, hopefully you know your alphabet, A, B, C, D, E, F, and so on, is carbon 1. But I'm going to give you a gift. I am not going to hold you to this numbering in terms of which is the carbon with the highest priority, but I will always hold myself to that. Shh, don't tell anybody I'm being nice. Ruin my image around here. So, since E comes before M, I'm going to call this carbon 1. Now, if I number counterclockwise, the methyl is on carbon 3. If I go clockwise, the methyl group is on carbon 5. And you go in the direction that gives the overall alkyl groups the lowest number. So I'm going to pick 1 and 3. And what that means is the name would be 1-ethyl, 3-methyl. I did it again. 1-ethyl, 3-methyl cyclohexane. Let's go through this again. You find how many carbons are in the ring. Hexane, 6 carbons. Don't forget, for a ring, use the prefix cyclohexane. Then we have a methyl and ethyl group. And the number 1 that has the highest alphabetical priority, close to the front of the alphabet, is numbered 1, and the other one is numbered 3. And therefore, it's 1-ethyl, 3-methyl cyclohexane. But since I'm not going to hold you to this numbering, I'm not going to hold you to the alphabetical rule, Don't tell the IUPAC police on me. But anyways, there's no IUPAC police. But anyways, I would accept 3 other answers. I would accept 1-methyl, 3-ethyl. So it'd be 3-ethyl, 1-methyl, and you could have the order reviews switch, and that would be 3-methyl, 1-ethyl cyclohexane, and you could have 1-methyl, 3-ethyl cyclohexane. So on this one, I'd accept 4 answers, even though in reality it's just 1. Let's go through another one. And you know something? Instead of, we got time. Let me redo this because, let's do it. Why don't you do this? And this is 4 carbons, and it's to the end of 4 carbons. Let's go back. Wrong slide, wrong thing. 4 carbons, and the N carbon, that's called an N-butyl group. 4 carbons, N-butyl. And how many carbons in the ring? I'll let you find out first. And the answer is 5. And remember, 5 is pentane. So what would be the IUPAC name for that molecule? Your turn. Oh, hint, B comes before M. Remember, you're just starting out. If you're having problems, that happens. They happen to me. If you have questions, come to my office hour or ask during class. If you're taking on the video, watching the video, ask, come to my office hours. You can also email me too. Yes, I do read my email twice a day, usually very early in the morning and late afternoon, maybe early evening. All right, let's do this because it's about time for your break. It's after your break. Hold on. We have here a ring. 1, 2, 3, 4, 5. That's pentane. It's a ring. It's cyclopentane. Here, 4 carbons and carbon and butyl. 1 carbon. Oh, it's your old friend, the methyl group. And B comes before M, so that's 1. Well, that's a weird color. And if I go this way, that's 2. If I go the other way, 1, 2, 3, 4, 5. Which is smaller, 2 or 5? And hopefully I'll pick 2. So this is 1 N-butyl, 2 methyl cyclopentane. Again, 5-membered ring, pentane, it's a ring. Don't forget the prefix cyclo. We have a methyl group and an N-butyl group. And this would be the B. Forget about the N. That's why I'm not holding you to the alphabetical rule, because a lot of students count this as an N. Prefixes are not counted. So it would be 1, and then methyl group is on 2. Now, there are 3 other answers. If you put 2-methyl, 1N-butyl cyclopentane, I'd accept that. You got the number switch, I accept that. If you got the names and number switch of the alkyl groups, I'd accept that. And if I look at the clock, it's 3:48. Come back at 3:53. Take 5 minutes and time for a break. And back in 5. Time to get going again. All right, quick little thing I just thinking about that has nothing to do with organic chemistry, but I thought I'd just tell you about it. The pandemic is still going on out there, not as bad as when it first started, but I personally have had both my original shots, Pfizer, and I've had not one, but two. 2 weeks ago, I got my second booster. If you don't have your shots and if you're eligible for boosters, get them. It's still out there. And I've noticed when I've been out for a while now, I'm still one of the few people who wear a mask, but at my age and risk group I'm in, yes, I'm going to wear a mask too. But anyways, let's get back to nomenclature. Remember, nomenclature is not the most exciting thing in the world right now. We'll get to better stuff later, but it's an important foundation. I was also thinking years ago when I first learned German. And by the way, I worked in Germany for one company. They had a plant and a research center that I'd visit. It was headquartered in the United States, but I go there for a couple of weeks at a time. And if you ever took German, and other languages are similar, you'd learn conjugation of verbs like to be, ich bin, du bist, ist. See, I still remember that. Sind or wir sind. But anyways, organic chemistry, what you're learning now is the same thing. Now, here's, as I've shown you, here's the structure, give the IUPAC name. Now, there's another key skill in nomenclature. Remember, nomenclature is the fancy word for meaning to name. Oh, by the way, hint, you'll find out why I do this after test 1, 2. And the question is 3 points each. Draw the structure for ethyl cyclopentane. And by the way, on my tests, I type these, I don't handwrite them. So how do you do this? Well, like all organic chemistry names, molecule names, you start from the right and move to the left. And the first one we say is pentane. And once again, it's time for me to go into overkill. Hopefully by Thursday or Monday at the latest, you've learned this chart, the number and the name, number of carbons in the name, IUPAC name, and pentane is 5 carbons. So we have pentane, but oh, look, we have the prefix cyclo, and that tells me we have a ring, 5 carbons. And as we go further, ethyl, and again, overkill time. I really want you to do well, and this is important. What's ethyl? Hopefully by Thursday or Monday at the latest, you'll have memorized this chart. Ethyl is 2 carbons, CH3, CH2. Remember, on a ring, we don't show hydrogens, and therefore, I'm going to put an ethyl group. Most of you would do this. And you could put the methyl CH3 group on the right also, but this would be correct also. And all I've done is rotate this ring around to get this orientation. And there are other ones. So you start from the right, move left, pentane, 5 carbons, cyclo, a ring with 5 carbons, and then an ethyl group on the carbon. Your turn. Draw the structure for methyl cyclobutane. In case you haven't learned a table, butane is 4 carbons. Remember, if you finish early, please be patient. I try and give almost everybody time to finish. Unfortunately, since we're not face-to-face, I can't look around the class like I would face-to-face and see if you're done. And therefore, and I can't even say, because you're not putting on your camera, smile when you're done. You give me a thumbs up, but I'll launch the poll. All right, let's get going. How do you do this? You start from the right and move left. Butane, 4 carbons. Oh, cyclobutane is a ring. And a ring with 4 carbons, you call square, we call that a ring. And then on a carbon, I have 1 methyl group on the ring. And I could put it here, methyl CH3. I could just as easily put it on any of the other 3 carbons. I could put it here too. And these are the same, all you're doing is rotating the ring. So start from the right. You see butane, one of the names from that table, the IUPAC names for alkanes, and that's 4 carbons, but cyclo ring, 4 carbon ring is a square, and methyl CH3 is on there. All right, let's do another one. And if we look here, we have 1-tert-butyl, 3-ethyl cyclohexane. I'll do this one, then you know I'm going to let you have fun, do one on your own. I'm not going to hog all the fun. And you start from the right, move left. Hexane, you've learned from the table, is 6 carbons. Cyclo, that's a ring with 6 carbons. And on carbon 3, we have an ethyl. Ooh, this is the one I haven't used. And carbon 1 is a tert-butyl. What's a tert-butyl? Oh, let's find out. And if you look at the bottom, a tert-butyl, or later on, I'm going to be like I am, a lazy organic chemist, which we call T-butyl. And Dr. White loves T-butyl groups. They've been good to me. I've been good to them. And that's 3 carbons attached to the center carbon, which is attached to the ring or long chain. In this case, a ring. So how do we draw a tert-butyl group? I'll call the top because most of you are going to do that. T-butyl, 3 carbons attached to the center carbon. Remember, there's 4 bonds to carbon. This is carbon 1. And then on carbon 3 is an ethyl, 2-carbon alkyl group. And you can go clockwise or counterclockwise. I would bet all of you are going to go clockwise. Here's carbon 3. And we have our, starting from the right, hexane, cyclohexane, 6-membered ring. Carbon 3 is an ethyl group. Carbon 1 is a tert-butyl group. And here's my tert-butyl group. Carbon 1, then 2, 3, my ethyl group. And that's how you do it. Oops. Come on. Let's try this again. And your turn. Draw the structure for 1-ethyl, 2-methyl cyclopentane. 3 points each if we're on something in the future. Hint. By the way, pentane, 5 carbons. All right, let's do this. And if we start from this side, always start from the right when you're trying to decode, figure out what to draw for, again, a chemical name, IUPAC name, and we see pentane. Pentane is 5 carbons. And oh, look, cyclopentane, that tells me I have a ring. And once again, I'm thinking a little greenhouse is a monopoly, and that's cyclopentane. On carbon 2 is a methyl group, and carbon 1 is an ethyl group. So I'm going to call this 1 because most of you will do. Ethyl, CH3, CH2. And this is carbon 2. You could call them the other way too. Most of you won't. Methyl group CH3. And that's how you do it. Remember, start from the right, move to the left. Pentane, 5 carbons. Cyclopentane, a ring with 5 carbons, 5-sided. Methyl group on carbon 2, ethyl group on carbon 1. And that's how you do it. Hopefully, guess what? You've been doing organic chemistry, and hopefully it's not that painful. All right, let's move on. Now, I'm going to turn the switch. Will this ever be on a tester of vinyl? Click to the off position. When it comes to boiling points, which is an important physical property of alkanes, the more carbons you have, the higher the boiling point. Now, if you have 2 isomers, the more branched it is, the lower the melting or the boiling point. I won't ask that on tests, but certain entrance exams, they ask that. So that's why I went over it. Again, the more carbons in a chain, the higher the boiling point. If you have 2 isomers, the one that's more branched has the lower boiling point. Now I'm going to skip this. I should have taken this slide out. Sorry. All right. Now, the fun part of organic chemistry, at least for Dr. White, me, is doing something with it. Now, we will be doing general reactions. And general reactions are like, if I take this top off and go like this, the water is going to come out. And if I have different bottles, different types of caps, and even different liquids, whenever I do this, it's going to spill out. Well, in organic chemistry, the beautiful part of it, and it really is beautiful, I love it, and that is, now you know I'm really an organic chemist, is that you have certain groups, functional groups, ways, things, of types of molecules, and no matter where they are and what type of molecule, when you do a certain type of conditions to that, you'll get the same type of reactions. And so let's look at the first general reaction you're going to have to learn. And that's combustion. And if you take an alkane, and I should also put here, take an alkane or a cycloalkane, react it with oxygen, you need a little spark, you'll get carbon dioxide, CO2, water, and heat. Now, I'm only interested in the molecules you have, so you don't have to put down heat, even though that's an important part of this reaction in our world today. So what does that mean? Let's look at the following. And let me remind you, in a chemical reaction, A plus B makes C. A and B are called the reactants, or reactant. But since I've come from industry, spent most of the good part of my adult life in the chemical industry, more likely than not, you'll hear me use the word starting material or materials. On this side, C is called the product. And if there were more than one, we call it the products. So give the products 3 points or products for this reaction. So what do? You look at this and say, oh, that's propane. That's an alkane. But it could have been a cycloalkane. Plus oxygen. And I learned this general reaction. And you've learned this general reaction, alkane or cycloalkane. Oxygen gives me CO2, carbon dioxide, and water. And therefore, if I take any alkane, and propane is an alkane, oxygen, I will get carbon dioxide and water. Now, unless you're measuring or trying to figure out charge weights, how many pounds or grams of each to react to make how many pounds or grams of a product, which we will not do in this class, I have done, and I've done up to 180,000 pound charge weights. Yes, in the chemical industry, I've done that. That was part of my job at a couple of companies. You don't have to balance a chemical equation in my class. Let me say that again. In my class, we will never be balancing chemical equations. Thank you, Dr. White. You're welcome. So we're done. So the key thing is know this general reaction. Hold on. This happens once in a while. Hopefully soon I'll be getting more memory in my machines, so this won't happen. Nope, I lost it. But anyways, that's not what I want. And let me get this back on there. Like I said, I'm waiting for extra memory. This is a problem I have sometimes on this machine. Sorry about that. So this is a general reaction that you need to learn. And if I look at the clock, it tells me, didn't know my clock could tell me things. Oh, that was awful. I apologize. But anyways, it's time for lab. Today is a Tuesday. I know that because I put out my garbage this morning. So it's a Tuesday. So what that means is it's lab time. Now, the way I develop labs for online, you're not going to be able to, and we can't do this in home, mix chemicals, even though it is fun to do that. And we were face to face. And most of it online, like all of them, simulations aren't that good. So what I did is I came up with a way of teaching you how to think about, learn about the things you would have done if we're face to face. Now, let me close off some things. Let me open something up. Next, talk about it more tomorrow in the syllabus because we've only got about 20 minutes left. I don't go over. That's not polite to you. And let's see, where do I want to go now? All right, thumbs up, people. Do you see D2L on your screen? Thank you, Alex, and Jimmy too. All right, now for the rest of the semester, for labs, you'll need to go to the assignment area. And let me go to student view. Go to the assignment area. And you'll see lab number 1. And I have both as a Word document and as a PDF. And later on, when you need to upload this, if you don't have a scanner, I have 2 different ways you can do it with Cam Scanner. And don't buy the professional, use the free version, that's all you need, or instructions how you can do it with your cell phone. Now, here's the melting points lab, and let me open it up, because that's today's lab. Thumbs up, people. Everybody see melting point lab on your screen. Thank you. All right, let's talk about melting points. Melting point is when a substance goes from a solid to liquid. And melting point is that. But before I do that, let me just tell you something important. Watch what I'm doing, take good notes, or you can go back to the video because my introduction will help you do the lab. Take good notes, so I'll help you do the lab. Don't tell the instructor I told you. It's Goofy Tuesday. All right, so melting points are unique for different compounds. Now, inorganic compounds have very, very high melting points, but organic compounds are less than 300, actually a lot less than 300. And there are 2 reasons organic chemists use melting points. And one is to determine the identity of an unknown compound. So melting points first will help you identify compounds, ID them. Second is to determine purity of an organic chemical, purity. So the 2 reasons organic chemists do melting point is to identify a compound that's a solid, or find out, is it really pure? And the melting point of pure compounds is a physical concept. It's always the same if you do it right. And melting points are ranges. And if we're in a lab, I'd show you face to face, and I've got a YouTube link you can watch on your own, and you should, especially at 542, how to do a melting point. Now, when you do a melting point, it's a range. And the beginning of the range is when you see any liquid, when the compound begins to melt. And the end of the range when the entire sample is a liquid. So let's do that again. They're a range. The first number in the melting point for organic chemicals is when you see any liquid in your sample. And when it's all liquid, your sample, that's the finish. So if you have compound, I'm going to be original here, X, hold on. Oh, it's a wrong number. 2 more rings. I'm sorry about that. It's not the president of the United States or the governor. I have a Bluetooth phone. Thank you. All right, you have compound X, and the first place where you see any liquid in the tube where you're measuring the melting point is 101 degrees Celsius. And at 103, it's all liquid. The melting point for compound X is 101 to 103. Now, if you get a melting point, let's see, they have sharp melting points. And if you don't get the right melting point, you know it's impure. Now, there's something I need to talk about. Oops, I got an empty. I have here the procedure. You can read that on your own. Now, there's something called the colligative effect. Hopefully you learned that in general chemistry. When I teach Chem 112, I teach that, and 101 also. I've never taught the 140 series. But anyways, when you have two substances with different melting points, if you mix them together, the colligative effect, the melting point gets lower and wider. You have two substances with the same melting points. If you mix them together, the melting point drops and gets wider. And in this lab, if we were face to face, and one of the nice things about these labs are, you find out, am I lying to you? Yeah, I might be. No, I'm not, but I might be. And part of the lab, you'd be doing this and actually experiencing. I have a mixture. If we were face to face, you do separate compounds, then mix it. And if we look at the lab, I give you the data. If you were face to face, notice biphenyl. Generally, if you're, whoops, hold on one sec. If you're new to organic chemistry melting points, a rookie, you're going to get numbers a little lower than what's called the published or literature values. And biphenyl, if you notice, I have down here a table, biphenyl 70, 71. In real life, you're going to get it lower, 68 or 67 to 70. Same thing with benzoic acid. Then urea, if you were to do this, this is what you got. And tranexamic acid. Notice they have the same melting points. And if I mix a 50-50 mixture, colligative effect, lower, wider. And this is about what you see in the lab. Now, normally you would be filling in that table, but since you're not going to do this at home, I've given you the data. Now, remember I talked about colligative effect. And if you have two things with the same melting point that are different, your melting point will go down and be wider. What if you have two things with the same melting point? One you know, and one you think it's that stuff. You put them together, then that should be the same melting point. Purity. Something's pure, not a mixture. You should get the right melting point. You won't have colligative effect. If they're the same thing, you don't have a purity problem. You'll get the same melting point. So today's lab, what you'll do the melting points up here, 1 through 5 for the samples that are known. And then to make it fun, I have an unknown sample. And to make it real fun, the district attorney of Kane County, that's where ECC is located, has a criminal and wants to, or someone who he thinks he's a criminal, convicted, wants to convict him of a heinous crime. I'll let you fill in the blank, what's the heinous crime? And they have to find out, the district attorney at Kane County has given us a sample and find out what's the identity of it. Well, how do you do that? Well, you measure the temperature of melting point of the unknown sample. And if we were face to face, you do that. And then based on that, you pick what you think it is and mix it together. And if the melting point is about the same, it may be a little lower, but it's going to be the same, you know that's the identity of the unknown. And that's how melting points can do identity and also purity. And the colligative effect, there's two ways of doing ID. Just looking up in a book, what's the melting point, or now on the internet, or mixing an unknown with a known. And if the melting point doesn't change, they're the same. I'll say that again in slow motion. Take a known and what you think it is, unknown, I should say, and unknown. And if you mix them together and do the melting point, and the melting point's about the same, then you know the unknown is the one you mix it with. And I have that for you in this lab. And here, sample A, the melting point is 118 to 120. And I would tell you the unknown is from this table. And based on that melting point, you're never going to have a melting point of an unknown a lot higher than the known. It won't happen. It's always the same or a little lower. You pick two things to test it with. When you add benzoic acid to the unknown, the melting point is 117 to 120. When you add the unknown A with cinnamic acid or tranexamic acid, notice it's now 100 to 125. For this lab right here, you have to fill in what's the unknown organic compound A. And it's one of these four. And use the concept of colligative effect. If they're different, even though they originally have the same melting point, or even different ones, it's going to go lower and wider. If they're the same, it won't change hardly any bit. Now, at the end of the lab, you have some questions to answer. And my questions, I don't expect a whole 5-page answer. Notice I give you enough space. Usually I give you more than enough space, like too much. And you answer these. Now, what I should mention, I really should go through it. Labs, and I'll do more on tomorrow, I'll mention it. But labs are always due the next lab period. And so for this lab today is due Thursday, where you upload it as a single PDF file to the assignment area I just showed you. If you have trouble uploading, let me know, or contact the computer group at ECC. Either I or they will help you out. And so if you don't have a printer, you have to answer what is the identity of compound A, and then answer the questions. You don't have to write out the questions, just put one, your answer two, and then upload that. Again, if you don't have access to a printer, which some of you might not, but if you're handwriting it, yes, I can read cursive, but make sure I can read it. Some of my students are like, I got to get a jeweler's loopy out and say, oh, what the heck is that? Yes, I have interesting toys. But anyways, I'm done. If I look at the clock, we'll get out in a lab day, usually do get out a little early. I'm done. Remember, in Yiddish, gehen gesund means go and help. And since the pandemic started and we were doing online, I started doing that, something my grandmother always used to say when we leave. She'd say, bye, gehen gesund. So I'm going to say, gehen gesund, goodbye. I'll see you tomorrow, same time, same Zoom channel. Oh, that comes from Batman too. Anyway, I'll see you tomorrow. Gehen gesund. I'll be uploading, doing the video later today.